we don't need to post it until we find out for sure from you.
Okay. Does it become public then?
It doesn't have to be. I was
Okay.
just thinking that I know there's a few people that aren't able to get on the call
Okay.
today that might be interested in hearing it. So
Mhm.
if that's okay with you.
Yeah, that's totally okay. Even if it's public, it's okay with me. I just don't know, like, if how NCHRP
Yeah,
feels.
and we won't share it unless you would, unless we get the okay from you.
Okay, that's great. Okay, so I'm new to go to meetings, so just bear with me. No. Okay, how do I hide this? Okay, excellent. All right, so can everybody see my screen now?
Yes, we can.
Excellent. All right, so like Sarah said, I'm Pinar Okumus from University at Buffalo, and Ed and Dan were supposed to join us, and we were all part of this domestic NCHRP domestic scan on innovations for concrete bridge decks. So I'm going to try to summarize what we discussed over a whole week-long workshop in about half hour. Our motivation for the scan essentially was to talk about three different things. So either materials, construction practices, or design practices to improve deck durability. We did actually talk about other things like environmental sustainability or accelerated construction for decks, but it looked like for most participants of the scan, durability was the #1 motivation to make decks better. So in case you're not familiar with the NCHRP scans, essentially is we bring together transportation agencies so that there is information exchange between the agencies. So it's all different practices of different transportation agencies. All right, so this is these were all the states that participated in the scan. So the green ones are essentially member states, so they were part of the scan team. And the orange ones are the agencies that we identified with the scan team and invited for the workshop. So it essentially goes like this. We do a literature review, and then we kind of figure out where the innovations are, then invite different agencies to a whole week-long workshop, and a report gets written on that workshop. So what you see here is essentially will be what's coming up in that report. And SME, subject matter expert, that's me. I acted as a subject matter expert from New York. Okay, so this is the contents of the report. So we discussed a variety of things that range from different concrete mixes, placement, construction practices, to fiber reinforced concretes, to corrosion resistant reinforcement, prefabrication, QA, QC, and design. So I'll go over, so these are the contents of the report. The report should be available in a couple of months. I won't have time to go through every single one of them, but there's a ton more information in the upcoming reports. But I'll try to give you an overview of what we discussed and what we found out. So I'll start with this first group, so concrete mixes, placement, and protection. And that part really, so our scan was focused on innovation, but this particular part is really more going to be about best practices and modern concrete mixes. So not too much innovation there in terms of materials, but what worked the best for the agencies that participated in the scan. Okay, so the first thing we really discussed was, what makes a concrete mix crack less. And one thing that really came out was the paste content of the mix. So it looks like for these modern mixes that have less cracks, the paste content is limited. So if you limit the paste content, which would be water and cement content, it does seem to result in fewer cracks. And of course, you also get a moderate strength, but the consensus was that we don't really need a terribly high amount of strength for concrete bridge decks anyways. There were some concerns from some DOTs about you don't always get what you specify. So it's good to shoot a little higher just in case there's material quality issues. So some states don't, because of that, they do want to specify higher strengths. But others are comfortable with moderate strength. They do experience less cracking with less cementitious material content. So I give 3 examples from the scan, so Kansas, Virginia, and Pennsylvania, and their cementitious material contents, especially Kansas DOT here, that their mix came from a pool fund study. So Dr. Darwin, who led the study from University of Kansas, gave a presentation essentially. So they did look at many different bridge decks, and they did actually see a difference between their old mix and this, what they call as a high performance mix. Okay, so the second thing to say about concrete mix was that limiting concrete shrinkage strains seems to have a big impact. So that's really a common performance requirement we saw when people had these high performance mixes. And some DOTs in the scan, they achieve it with shrinkage reducing admixtures. So California is a big fan of this, and they reported really greatly benefiting from shrinkage reducing admixtures and without really increasing the costs all that much. So in the report, there's going to be a case study from California DOT that details how they came out with that mix. So again, 4 examples from participating states here on their shrinkage strain limits, right around 300, 350 microstrain, and how they achieve that is kind of up to them. So for example, Virginia DOT uses shrinkage reducing admixtures, but it's an optional thing. So they can, if they can achieve the shrinkage strain without the admixtures, they're okay with that. All right, and then we did talk about placement and finishing, and again, this is really not innovation, but most DOTs agreed that you do get the best quality concrete when you minimize finishing, so that essentially you can start external curing or wet curing right away. So we talked about bringing these work bridges to site so that workers can start curing right away without, you don't have to wait for the deck to harden, avoiding timing and instead saw growing the hardened concrete for the same reason, so you could start right away with external curing. There was actually some DOTs mentioned some monetary penalties per hour of delay in external curing to encourage the contractors to start curing right away. So that was a big thing, essentially, to get started with external curing right away. Use misting even before then, if you can. And then there was a discussion about specifying temperature changes for plastic concrete, or trying to pour when the ambient temperature fluctuations were small, or at least when concrete and the contact surface, so that would be the girder. So if the concrete and the girder temperatures were very different at the time of the pour, it seemed like it was causing more trouble, and avoiding nighttime pours for that same reason. So controlling temperature as much as you can seem to result in better quality concrete. All right, so we did talk about external curing, like I said. So for external curing, which is wet curing like we all do, the key is to start right away. But there's this kind of new innovative way of curing concrete, which is called internal curing. And essentially what it is that you replace a fraction of your aggregates with pre-wetted lightweight aggregates. And that water in the aggregate is released over time to help hydration. So instead of just curing, or instead of just hydrating the surface of the concrete, you're essentially hydrating from inside out, so internally. So this was very interesting. We spent a lot of time on this during the workshop, that for some states, this is pretty much standard practice. So New York and Virginia were 2 of those states, so they do this for all their concrete decks, and they've seen great results. But for other states, they have mixed results with this. And we came to the conclusion that the states that have the good results must have good quality lightweight aggregates. And they can essentially, they're confident with the moisture content of the aggregates. Suppliers know how to store them. Versus if you do have mixed results, you probably either don't have lightweight aggregates at all, or you're not sure about the quality of it, or the contractors are inexperienced. And also, this is a method that requires a good amount of owner involvement to set it up right. So if there is insufficient owner oversight to get this method working, it seemed like that's when there was mixed results. So I would say New York and Virginia, those are the two states that really have all internally cured concrete, and they do get great results. Okay, so that's kind of what we talked about for when it comes to concrete mixes. And then the next thing we talked about was adding fibers to concrete. So that's what I'll cover next. All right, so mixes with fiber. So this is essentially, again, some agencies do this to kind of have an additional measure, kind of insurance essentially, to protect against any issues with quality of the material they get, concrete mixed material, or the construction quality. Because like I said, construction quality is big actually to make concrete crack less. So for example, maybe you do have delays in external curing, or workers ended up walking in concrete after finishing, after vibrating. So to protect against these unexpected or undesired events, it may be good to add fibers into the concrete. So again, California presented on this, and it is the standard practice for them to have fibers in their mixes. Minnesota, I believe, also has fibers in their deck mixes. But one important thing that got emphasized was that if you just add fiber in your mix and think that it's going to work, that's probably too naive of an approach. So the type of the fiber, there's various different types, various different suppliers, size of the fibers, orientation, distribution, all these things impact results greatly. So it is an iterative process to essentially come up with a mix that works. And of course, adding fibers also changes workability of the mix. So just like any innovation, doing some iterations and improving over time is what's needed here. Also, one recommendation that's going to come out of the scan is we do need some testing methods and acceptance criteria for to be able to approve different fiber types and suppliers. So I know Minnesota has approved list of suppliers, for example, for these fibers, but not everybody does. So maybe some national acceptance criteria and tests are needed. Okay, so the next thing was ultra high performance concrete, UHPC. You've probably all heard about it because it's such a popular topic right now. It's essentially a type of fiber reinforced concrete. Usually the fibers are high strength steel fibers, and the UHPC is essentially a fiber reinforced concrete with a specific performance objective, and that performance objective is, well, it has very high compressive strength, more than 22 KSI is possible, which again is not so critical for decks to achieve, and it has low permeability, so very high packing density, low permeability, so that makes it very durable, and that makes it attractive for deck applications. So we discussed multiple different applications of UHPC. I'll give you some examples. So one of them was link slabs. So this is essentially that piece of the deck that goes over the supports or connects two girders, or between two girders. And actually link slabs are used with conventional concrete as well, but they tend to be much, much longer. So New York has started replacing some of some bridges, bridge decks with expansion joints with these link slabs, and they reported that they've had great performance with these. So essentially, when they switch to UHPC, they now can have a link slab that's much shorter, so just a couple of feet, you can see on the right-hand side. And the thickness is also smaller too. So that completely eliminates the expansion joints, and that's how they get durability. So it's essentially acting like a hinge on top. That's why they debond between that UHPC layer and the girders. So like I said, they've done several bridges with this. They've replaced them. This is mostly for replacement projects for them, but they still have many to come. So they're going to continue to build these. Okay, the second example with UHPC applications is deck panel joints. So these would be precast concrete deck panels. UHPC, as you know, is much more expensive than conventional concrete. So most of the applications you see would be small volume applications. So this is an example of that. So precast concrete panels, either between the two panels or between the panel and the girder, you can use UHPC. And we heard during the workshop from Utah and New York, and they both reported that when they did use UHPC joints, they actually got pretty much equivalent performance to post-tensioning these deck-to-deck joints. So if post-tensioning is not a desirable construction method, UHPC seems to be a little bit easier. So one interesting thing here is that on the right-hand side, that's New York's hidden shear pocket detail. So you see that there's actually not a whole pocket, but from the top you would only see that little tiny hole to let UHPC run through. And the UHPC layer between the deck and the girder is essentially sufficient to transfer the shear between the girder and the deck. All right, so here are some really key points in making UHPC work. And this is not just for these two applications, but for any application. I didn't cover it all with UHPC. So one very important thing is that to really seal the forms against leakage, because UHPC is a lot more flowable than normal concrete. So that's why you see on the right hand side that there's actually a top cover as well for that form. So you do have to seal them. And it's a material that tends to settle a little bit. So when it hardens, so you actually essentially fill the joints a little bit more than you need to, accounting for that settlement. So that's why there's that bucket here. It's essentially maintaining hydraulic pressure over that joint. And if you do have a little bit extra, that can get grinded off later. The other key things is that if you're pouring UHPC at point A and expect it to go to point B, and those 2 points are very far from each other, and UHPC is just going to flow a very far distance, then what can happen, what people reported happening, is the fibers essentially all orienting in the direction of the flow, which is very undesirable. So we do want a random distribution of fibers. So keeping those flow lengths short is recommended. And then just like any application, actually, with connections, roughening the concrete surfaces, so that if it's a deck panel to deck panel joint, having a roughened surface on those shear keys helps. And also very important, again, to bring those the panel joints or whatever joint it is to a saturated surface dry condition before placing UHPC really makes a big difference. Some DOTs reported that they require the supplier of UHPC to be on site to help with these things. Especially, I mean, if it's a proprietary product, one reason why the material is so expensive is it does come with support. So especially if the contractor is not all that experienced, it may be a good idea to have that requirement. All right, and then finally on this one, on the UHPC topic, like we discussed, UHPC, the proprietary mixes can be very costly. Although there are now multiple vendors, suppliers of UHPC, and the cost is expected to go down. Many states and universities are now developing their own non-proprietary mixes. So I give 3 examples here from Iowa, Michigan, and Texas, because they participated in the workshop, in the scan, but really there's many others across the country. So everyone is now coming out with their fiber reinforced, low permeability UHPC mixes. All right, so next I'll move on to corrosion resistant reinforcement. I don't know if it's better to take questions at the end, probably for time reasons, but if there's any burning questions, please feel free to unmute.
Yeah, either way will work. We have plenty of time, so if you need more than 30 minutes, please, you're fine.
Okay, that's great. Thank you. I thought I saw that in the chat. Great. Okay, would anyone like to? And I saw Ed sign in, and if Ed, you want to add anything at any point, feel free to. Okay. All right, so we did talk quite a bit about corrosion resistant reinforcement as well. Although one theme that came out of the workshop was that if you can control cracking with the concrete mix itself, so if you can come up with a modern mix, if you can come up with a low shrinkage, low paste content, high cost construction quality mix, then that's really the best option. So that should be prioritized. And corrosion resistant reinforcement really kind of should come next. So maybe it comes after it's used for bridges that are just very remote and very hard to maintain, or have, it's very hard to access. So in those cases, corrosion resistant reinforcement could be a good solution. So any of these corrosion resistant reinforcement bars, we did talk about taking kind of like a service life approach to justify the higher initial cost. So again, service life approach, like, do we need 100 years of service life, 100 years of deck service life, or can we just go replace the deck? Maybe then it's not needed. Okay, so I'll start with fiber reinforced polymer or fiber reinforced plastic FRP rebar. So there's different kinds of FRP rebar, glass FRP, carbon, aramid, but glass tends to be the most common, is cheaper. So most of our discussion focused on glass FRP rebar. And for this one, we heard from Florida DOT that has used FRP rebar actually since the 80s. And they have great websites, a great website just dedicated to their FRP research. They have essentially developed applications, concrete applications with FRP rebar. Although most of their applications are for substructure units, because in Florida, the corrosion starts from the salt water, not from the de-icing salt. So you see a lot of piles and substructure units, essentially. So the differences between FRP rebar and metallic reinforcement is that it doesn't corrode, it's not metallic, so that's great. It's very lightweight, so it's very easy for the construction workers to pick them up and move. So it does facilitate construction, actually. But there was some discussion about how the FRP grid can actually, it may float during the pour, during the concrete pour, if you don't secure it well in its place. So you can technically get smaller covers, like smaller top covers, deck covers, reinforcement covers, because it doesn't corrode, right? We don't need that large cover. But just because some DOTs were worried about the floating issue, they still went with a larger cover. These bars do not yield, so they essentially are elastic and then they fracture. So because of that, design is very different. And the design is often controlled by crack control requirements, because the glass FRP, it's essentially not as stiff as our steel bars. So crack control usually controls design. The other thing to be wary of is that these FRP bars, glass FRP, it can get damaged easily during demolition or concrete removal. So that makes it pretty much impossible to replace a deck or widen it. But there were some workarounds for that. So for example, some agencies reported using steel metallic rebar towards the ends of the bridge, or the sides of the bridge, I should say. So essentially they're using FRP and metallic rebar together so that they could widen the bridge later on. So they could do some construction towards the ends without damaging the rebar itself. They cannot be field bent, so they do come pre-bent. So that's something to keep in mind. And most FRP products are proprietary. So that's actually, that has an advantage to it. So that means they're constantly improving their products, these companies. So essentially what you get, your FRP rebar from 10, 15 years ago is not the same FRP rebar that we have today. So one recommendation we had from the scan was to invest some funds to research these newer and hopefully better products, both short-term performance and long-term performance. Okay, then we talked about galvanized rebar. We're all familiar with it. I think the hot dip version of it, or batch galvanizing. So ASTM A767 bars have been around for a long time. A newer product is continuous galvanizing. So it's essentially, there's a difference in how they galvanize it, and there's one supplier of that in the US, and they do claim that it makes the operation a little bit more efficient. So you can essentially, the bars get bent and galvanized at the same facility. So if you're close to this facility, it may be a good option to go for. They do not have that issue with that epoxy coated rebar has with, bonding to concrete. So it's essentially similar bond to concrete as you would have with your black bars. And on this topic, we heard from University of Kansas again. So Dr. Darwin came, and their results show that both hot dip and continuous galvanizing, they essentially had similar performance. So they had some lab testing and field observations to show that. And they did run some service life analyses. So they reported that the rebar has a slightly higher initial cost, but you can get about half the service life cost as compared to uncoated rebar. So there were several agencies, most of them actually, so I listed a couple here: Minnesota, Texas, Pennsylvania, Utah, Washington. They all do provide galvanized rebars and alternative to epoxy rebar. So some of them require no additional cost, but some of them use it as needed. So like I said, if there's a need for more corrosion resistant rebar, this is an option for them. Okay, we did talk about stainless steel rebar. So stainless steel rebar, when it came to that, the conclusion was that it's an alloy, right? So not all stainless steel is the same. So really the performance will depend on the type of the stainless steel rebar. So one interesting thing that we learned from Virginia DOT is on the right-hand side. They do have these X-ray fluorescence handheld devices, and it can actually tell you the composition of that alloy. So they were using it to verify essentially what you specified was the same as what they received from the manufacturer. So that, I think, is the quick way to check the alloy, and of course, like specifying the type of the stainless steel on the specifications is important. So We heard from Virginia and Michigan about the cost of stainless steel. So Virginia reported a 5% additional total cost if they use stainless steel in the deck. And their justification is that the cost may be smaller than a future overlay, which makes sense. Michigan DOT reported about $17 a square foot of additional cost, and that's, again, 2011. All right, so ASTM A1035 bars is another alternative. You may have heard these with their brand names, MMFX or Chromex now. So these are, again, chromium alloy steels, and there's 3 different types. CS, CM, and CL. CS is provides the highest corrosion resistance. Of course, it has the highest price. They come with either 100 KSI or 120 KSI yield strengths. But actually, most agencies that participated in the scan, they reported that they choose not to rely on that high strength, so they just use it as a one-to-one replacement of our good old grade 60 steel, or just like cap the yield strength in the design to be conservative. And there isn't all that much data available for the long-term performance of these bars. So most states use the CS type because that's supposed to provide the most corrosion resistance. And Minnesota reported some quality control issues with the CM type. So the manufacturer is aware and working on that. The cost is a little bit higher. I put the Michigan DOT numbers here, so $2 to $3 dollars a pound versus $1.5 to $2 a pound for epoxy coated bars. All right. So the next step is that we talked about prefabrication of decks, and that's for both accelerated construction and also durability, because you're getting prefabricated units that are, steam cured, built in a higher quality environment. I won't go into every one of these categories, but like I said, the report has a lot more. All right, so I think I picked 2 here. So one is the partial depth precast deck panels. So these are essentially like stay-in-place forms that may be pre-tensioned. So about half the deck thickness, and they provide a safe walking surface and formwork, essentially. So this one we heard quite a bit from Texas DOT, because this is apparently more than 90% of their bridge decks are built this way. So this is essentially standard practice to use stay-in-place or partial depth precast deck panels for their deck construction. And we do know from the other states who participated in the scan that not everybody has a great experience with this. Some other states, for example, have reflective cracking when they use these panels. But Texas told us about their keys to success. So 2 important things that we noted from there is that, one, they have these bedding strips. So that's that on the upper right, figure on the upper right, the black rectangles that you see are the bedding strips. So essentially, they have these bedding strips that are a particular size. And the reason why it's there is because they want to make sure the cast-in-place concrete gets under the precast deck panel and is well consolidated under that deck panel, and it becomes a good permanent support for that deck panel. So the cast-in-place consolidated concrete is the support permanently through the use of these bedding strips. And the second key point they mentioned was that just like you've heard me talking about UHVC, really bringing these panels to the saturated surface dry condition by pre-wetting them you get great bond between the 2. These bedding strips are flexible, I believe. So they are kind of like blue foamish material. I wish I knew the formal type of the material. All right, and then we talked about full depth precast decks, deck panels. There we talked a little bit about it when I talked about UHPC, but great for rapid construction, or if you're far from an area with concrete suppliers. So we heard from Utah DOT, New York DOT, who use these full depth deck panels, and they're happy with them. We also heard from California DOT, who the bridge was fine, but it was quite costly when they tried it. And that's because they used it on a bridge with a complex geometry. It had a curve, so likely costly alternative if you have geometry, but if you don't, then it seems to be a pretty good alternative. And for this, again, joint details and materials are critical. So Utah told us that, again, either they post-tension the decks together or they use UHPC. So that's equivalent to each other. So either of those joints perform well. In the past, they had the much wider joints with normal concrete, and those had the cracking between the panels. So the joints didn't perform very well for those. Because UHPC bonds so much better to reinforcing bars, your development lengths are much shorter, so you can go with much smaller, you can see on the left-hand side, joint sizes with UHPC. And on the right-hand side, again, is that hidden joint detail with from New York. We did talk about decked girders. So some states develop standard plans for these deck girders. So these are essentially girders that come with a either partial or a full prefabricated deck, integral. So the one on the left is a deck overhang from Texas. It's a partial deck overhang. They do provide this, they said, as an option for contractors, but not very many chose to use it at this point. And there were some concerns from other DOTs about having a thin overhang, just developing cracking, even during construction. And on the right-hand side, we have these decked girders in Washington that come with the full deck, and great for accelerated construction, but of course they're heavier. So these have been more limited in their use, but they're out there. The other examples you may have heard are, next beams and all the others. All right, so coming towards the end, we talked about design, how design and detailing practices may improve deck performance. So I'll give you a couple of examples here again on that. So one thing that came up was that we realized is that really there's quite a bit of variation in design and detailing practices among states. And even within a certain state, these design and detailing practices vary over time. So something very important to note here is that because these things change over time and from state to state, it's really critical to document the implications of these changes. So it's great to keep track of innovations. So if you're changing something in design, was that successful? Did it do a good job? Both short term, but also hopefully long term. So some examples of these varying practices. Well, some people use, of course, the empirical deck design method. Some others use the traditional. One example here is the Minnesota deck. So they actually intentionally create a little saw cut over the supports to intentionally force the crack to occur there. And that way you restrain cracking to that region and you don't have to kind of worry about cracking all over the deck. And the Texas DOT also mentioned that they do something similar to this. All right, and then next up, Texas DOT again discussed how they reduced the amount of reinforcement they have indexed as a method to reduce cracking. And that may sound kind of counterintuitive, but their reasoning here is that if you have a smaller reinforcement amount, the corrosion products that build over time are going to be small, and that's going to create less pressure when they expand, and that's going to result in less cracking. So they switched the empirical method, Ashton's empirical method, to be able to get a smaller reinforcement amount as compared to the traditional method. The other change they made is that the very top layer of rebar, as you see in this cross section, is the longitudinal rebar. So the longitudinal rebar, they place it closest to the top surface. And the reason for that, again, is that because their prevalent cracking was in the transverse direction, so the longitudinal bars restrain those cracks better. And this did help them reduce overall cracking, even though, of course, they got much smaller transverse cracks, but they got more longitudinal cracks, but overall they did see a reduced cracking. So it seems like they're happy with these changes. Okay, and the last part. So quickly, we also talked about quality control, quality assurance, and different practices for making sure the workplace knowledge is there, or sorry, workforce knowledge is there, and it continues to be there. So in terms of construction quality practices, I think that everybody agreed that, especially if you're using an innovative product, something new, you have to be really well prepared for it. So here, some examples are there here. So for example, people use these test pours on the right-hand side. I give an example from Washington. So this is a test pour of a new mix. It could be on-site or off-site, but if the contractor does a test pour, they know what to expect with that, the rheology of that mix and workability of that mix. Pre-deck pour meetings, construction checklists. So on the left-hand side, I have the example checklist from Minnesota for a pre-pour planning the placement checklist. There's other ones. And of course, training people. We talk quite a bit about that during the workshop. Some DOTs provide, like Texas and Minnesota, they have training programs both for internal and external staff, inspectors, and they have certification programs as well. And then also frequently sampling both concrete by certified inspectors, and if you're using alternative bars, frequent sampling of that is important. We talked about how there have been some quality issues with even rebar, and especially the ones that are more alloys rather than pure material. Okay, and then in terms of knowledge continuity, so like I said, I didn't put it all here, but we did talk about training quite a bit. But what do you do when you do have the knowledge now, but with the workforce changing, people retiring, how do you make sure that knowledge stays in the agency? So like I said, one thing we know is that innovations don't just happen over time, right? It does require iterations. So if there was a champion of that innovation in the agency, and if they disappear, it shouldn't end there. So one thing that we discussed was to make sure to keep good track of these innovative projects, how they're doing now, but also how they're doing over long term. So that impacts decisions in the future. So Utah, for example, had a innovation-specific database or inventory for their bridges. So they have detailed information about performance, construction, all that, about new things they try. Florida, like I mentioned, they maintain great websites with all the research information, so research reports, demonstration projects, applications, specifications, they're all in one place, let's say for FRP or some other new material they're trying. Another one is, so Minnesota has agency-defined elements for inspection, specifically for any innovative components for their bridges. So all these things help keeping track of how these innovations are performing. Okay, so just to wrap it up, these were the recommendations from the scan. I think I mentioned all of them pretty much throughout the scan, so I'm not going to read again, but yeah, so document the innovations, training and certification, being prepared, investing in research for life cycle deterioration models to make decisions, right, more informed decisions. Yeah, and maybe one thing I didn't mention is number 8. We also did see a great benefit in exploring automated technologies for quality control. So that's going to be one recommendation. Yeah, so the rest I don't need to read. Okay, so this was the scan team, and I think Ed and Don are here, maybe. I put my email address here for any questions that you may have later. So this is our full scan team, and the scan management was done by Aurora and Associates. So I can take any questions with that. Sorry, I went much longer, but Sarah gave me the green light, so I blame her.
Yes, thank you, Dr. Gomez. Very, very good presentation. I know our group, and I apologize again, it's probably loud on my end here. I know the group has talked a lot about quality control and also about innovations and how to track them. So I think, I assume in the report there are some specific examples for all of these, right, from different agencies. And so I think that will be really valuable when the report is released.
Yes.
Does anyone, go ahead, I'm sorry.
Oh yeah, no, so I was just gonna affirm, yes, there's specific examples, and even like the research need I talked about, the technology-oriented quality control, so there's some ideas there in the report for that.
Excellent. Does anyone have any further questions?
I'll have Ed or Don take them.
I was just going to say I didn't have any questions, but Kevin Prusky works real closely with me. He had a lot of real good things to say about this scan, and we're looking forward to the report. One thing worth just clarifying, TxDOT does not have a certification program for bridge deck construction. We're working towards developing that. We do have some training content, but if that's the language in your current report, you might just revisit that. But I appreciate you talking to us today.
Yeah, no, so it does say in the report, Texas is working with a third party to develop a certification program. But here I kind of lump things to save time.
And would you mind providing your presentation to us so that we can distribute it to the members of the working group?
I sent you the slides, Sarah, but again, I'll check with Harry to make sure, Harry Capers here to make sure it's allowed to do that.
Excellent. Yep, that sounds great. All right. Well, thank you very much again. Ed, do you want to add anything? I saw you came off mute.
Yeah, thanks. First of all, thanks, Pinar, for helping us through this. I think there's a lot of herding of cats of information and tons of states' experiences and wrangling all that and putting it in a way that's meaningful and provides guidance and help to other states that weren't part of the scan tour. I think is really helpful. I found it super helpful. Some of the things that I really am going to take back to MnDOT and kind of try to figure out where our next steps and what we need to do is, I think the SRAs, I'm assuming you discussed that, has been discussed already. I think that's something that we have to look at. Obviously, internal cure, which we've tried, but maybe based on New York's experience, maybe that's something we want to pursue further. Fibers, certainly, I think have shown lots of benefit. And, just trying to figure out where your fibers are. And there's a lot of different details and a lot of different proprietary systems out there. And I think, no fiber is equal. There's lots of different varieties out there, and making sure you get the right type of fibers, I think, is important, and it makes up for a lot of construction kind of mishaps that can happen. So it's a little more tolerable situation. So I think that's something we need to look at. Also, I like the idea of the switching the reinforcement level, some of the detailing. I think having the top bar being longitudinal, that has some potential too. So I'd like to do that for us. But nonetheless, there was, lots of other things that we're going to take back into the study, and would love to share this with other states. Getting that information out there, I think, is super helpful for other states as they're trying to do it. As I always tell people that try to eliminate cracking. If you don't want cracking, then don't pour concrete, right? Like concrete's going to crack, and you just have to manage that, right? And so whether that's with different bars or with fibers and trying to control the crack size, or crack sealing, or whatever you're doing to manage that cracking, it's just, there is no magic bullet here. And we have poured concrete that has very small amounts of cracking, but there's cracking on any given deck, whether they're visible or whether they're micro cracking. They're going to be there, right? And so you just have to figure out how to manage that and minimize that as much as possible. And I think every state's been experiencing these issues for the last 10 to 15 years, and trying to manage that. And like I said, I don't think this scan came out with the silver bullet, but there's a lot of best practices in here, and there's a lot of things that every state can improve on. And so I think hopefully we'll get the word out on the scan. So I appreciate the presentation, Pinar, and helping us work through this. So I'm available for any questions on that, and it looks like Don has his on video on too, so maybe he wants to add on to this too.
Just very small. Thanks again to Pinar for presenting all that information. And to Ed's point, there's a lot of information. Great thing I got out of it is just talking to their fellow DOT members, and an exchange of ideas. And the biggest thing is having that connection to say, hey, have y'all tried this, or we're about to try this, and sharing that information. So again, thanks again, Pinar, for sharing this information today. Hope it helps a lot of people and get the word out. Thanks.
Yes, thank you, Don. I agree. I think these scan tours are just an excellent opportunity to share expertise and knowledge. And so I encourage all the state DOTs out there to be involved in those scan tours. And thank you again for presenting, Pinar. We just really appreciate the information. I think all the reports that provide recommendations or a summary of best practices from other states are really valuable. So thank you again.
Of course. And I
present
reports for David quick for the bedding strip material. It does say blue board, so it's in that. Okay.
Thank you.
Of course. All right. Well, thank you very much for having us.
Yes. And so for the rest of the group, we had some additional topics on the agenda. What we're going to do is actually postpone those to the next meeting, which was just discussing that process for annual database updates for the bridge product database. So I encourage you to look through the process that was on the agenda. It's a draft, and we want to talk through that at the next meeting. So with that, I'll thank everybody for attending and for your participation. And I hope you have a great rest of your day. Thank you.
Thanks, Sarah. Have a good rest of the day.
Thank you all. Bye-bye.
Great meeting, Sarah. Thank you, Pinar, and Don. Appreciate it.
I'm having a hard time hearing you, Nancy.
It's okay, no worries.
Okay.
Thank you.
I'll see you soon.